last topic this unit is solving multi-step inequalities, and we're going to build on that by writing in set and interval notation. So there are two ways to write our notation. Like I said, there's set, and that's the one we need to remember is with braces. So the way we read it always is the set of all x's, or whatever your variable is, such that, and then it's your inequality. In this case, x is greater than 0. So if we look over here, again, we have those braces, which indicate that we're talking about a set of numbers, and then we write our variable x, draw our vertical line, which indicates such that, and then we write our inequality and end it with a brace. So that's set notation. And then the other one is interval notation, and this is where you write the beginning and ending numbers with a comma in between, and then you use a bracket, a square bracket, to indicate that if it's a closed circle or the number is included, we use a bracket. And then we use a parentheses if it's an open circle, which means that the number is not included. So again, we look over here. This says the numbers between 0 and 20, and in this case, 0 and 20 are included because of those brackets. If we had something like this, that parentheses means that 0 is not included, but that 20 is. So you'd see an open circle on 0 and a closed circle on 20. That'll become a little bit more clear as we do some examples here. So like I said, today we're really focusing on set and interval notation. So in these first two examples, our solutions are already solved and graphed for us. We're just writing in set and interval notation. So we're going to start with set. Again, we use braces, which indicate that we're talking about a set of numbers, the set of all. Then you ask yourself, what variable are we talking about? Because it won't always be x, so you need to pay attention to that. In this case, it is. So the set of all x's such that, and then we write this inequality right here. X is greater than or equal to -2. And then we close our brace. So that's set notation. Then when we're talking about interval notation, we're talking about beginning to end. When we talk about beginning to end of our set, we read it left to right. So in this case, our furthest left point is right here. This is where we're going to start. Now when we're talking about arrows in math, because this says it goes on forever, what's that arrow heading towards? What's it pointing towards? If that arrow keeps going to the right forever, we're going towards infinity. So we write our beginning and ending numbers. So in this case, our starting number is -2, and it's pointing to the right, so it's going towards infinity. Then we have to talk about what goes around these numbers, brackets or parentheses. So because there's a closed circle on -2, it means it's included, and we write a bracket around it. Now with infinity, can we put a point on infinity? No. Infinity is just all the numbers that are, in this case, greater than -2. So we put a parentheses around there. If you have questions about example 1, please pause your video before moving on to example 2. In example 2, we're going to start with, again, set notation. We draw our braces, the set of all, what's our variable? X, such that, and again, we write this inequality right here. X is less than -1, and close our brace. Now, if you remember with interval notation, I said we read it left to right. So what is the furthest left point? Well, in this case, our beginning point is actually that left arrow. And our ending point is -1. So if that arrow is pointing to the left, what's it heading towards? As all those numbers get smaller, it's going to -infinity. and our ending number is -1. Again, what do we always put around infinity signs? Parentheses, and then we ask ourselves, is -1 included or not included? Because it's an open circle, it's not included, so we put a parentheses. Again, if you have questions about just set or interval notation, please pause your video before moving on, because in examples 3 and 4, we're just going to be building on this. So in example 3, the first thing we need to do is distribute. So 3 times x is 3x, 3 times 4 is 12, and then we need to do another distribution. What are we distributing in that second part? A -5. So remember that sign goes with it. So -5 times x is -5x. -5 times -1 is a +5. So I distributed. My next step is to combine like terms. Now, because these terms are already on the same side, we're just going to do the operation it says, 3 minus 5. 3 minus 5 is -2x. And then I have a +12 and a +5, which is +17. Again, we're not changing sides yet. So when I'm combining like terms and they're already on the same side, you just do the operations that are there. And now I solve for x. So subtract 17 from both sides, which cancels that out. -2x is less than 5 minus 17, -12. When I divide by a negative, what happens to my sign? It flips. So x is greater than -12 divided by -2 is +6. So we're going to go ahead and put this on our graph here. 6, 7, 5. Talking about open or closed circle in this example. I have an open circle and it's pointing to the right. Alright, set notation. Again with our braces, the set of all, what variable? X's, such that, and then we write our inequality. X is greater than 6. And then interval notation, we ask ourselves, what's our beginning number? So our furthest left point, in this case, 6. So this is where we begin. And then our arrow points to the right. So my ending is over here. So I'm going to write 6, comma. Our arrow points to the right. What's it going towards? Infinity. And then we just need to write our brackets or braces. So are we including 6? No, it's an open circle, so parentheses and what always goes around infinity signs, parentheses. Our last example here is number 4. So in order to solve number 4, we need to get our like terms on the same side. So 2r minus 5r is -3r. Minus 18 is greater than or equal to 3. My next step is to add 18 to both sides. -3r is greater than or equal to 3 plus 18 is 21. My last step, divide by -3. And when I do that, my inequality sign flips. R is less than or equal to -7. So when I draw this on a graph, remember when we're talking about negative numbers, what number is to the right of -7? Our numbers look like they're counting down. So -6 is to the right, -8 is to the left, open or closed circle, in this case it's closed, and it's pointing to the left. So with set notation, again, braces, the set of all, what variable are we talking about? In this case, it's r. R's, the set of all r's, such that, write this inequality, r is less than or equal to -7. And end our braces. And then lastly, we have interval notation. So again, we read it left to right. So when our arrow is pointing to the left, we begin over here, and this is our ending point. So we begin, if that arrow is pointing to the left, what's it pointing towards? Negative infinity, comma, and our ending point is -7. What always goes around infinity signs? Parentheses. And are we including -7? Yes, because it's a closed circle, so we put a bracket around that. We do have a few special cases to talk about. So if we solve these problems, again, we move our variables to the left, so subtract 5x from both sides, but what happens? 5x minus 5x, those go away too, right? So what's left? 2 is less than or equal to 2. Is that a true statement? Yes, so in this case, we have infinite solutions. If you get a statement that is true, in this case, 2 is less than or equal to 2, it's infinite solutions, and in order to graph that, you just put a line going over all the numbers. So it covers all the numbers. For set notation, we say the set of all, what's our variable? X's, such that X, and then we draw this E, includes all real numbers. So that R is all real numbers. And then interval notation, if this arrow, again, we read left to right, so if my left arrow continues to go this way and my right arrow continues to go that way, we're talking negative infinity to infinity. And what always goes around infinity signs? Parentheses. So if your solution is infinite, your interval notation is negative infinity to infinity. All right, in example 6, again, if we move our variable to the left, my 5x's cancel out, these 5x's cancel out, so what's left? 2 is greater than 2. Is that a true statement? No, 2 is not greater than 2, so in this case, no solution. Why was number 5 true and number 6 is not true? In number 5, we have this equal to sign, so 2 is at least equal to 2. All right, and then our last example is number 7, 5x, subtract 5x from both sides, these cancel, 5x minus 5x cancels, so I'm left with 3 is less than 2. Is 3 less than 2? Is that a true statement? No, so again, in this case, we have no solution. Those are the end of our notes. If you have questions before moving on to your UDOs, please raise your hand before you start. Otherwise, you can turn your paper over and get started.